Reaction of acid with alkali or base or base. So just like acid and metals, just like acid and metals, so acids can also react with bases or alkalis. And I told you in the last class that what is the identification of base and alkali. Okay, like oxides and hydroxides, they are bases. Okay, and when the compound is soluble in water, so that would be an alkali. So generally, generally, when acid reacts with alkali, or you can say base, whether it is soluble or insoluble, it would be forming salt and water. What's the difference between this and acid plus metal? In that reaction, hydrogen gas were produced, but in this reaction, water is produced. Are you getting my point? Yes or no?
Yes.
Yeah. So uh, it's also known as neutralization reaction. It's also known as neutralization reaction. Okay, neutralization reaction. So let's say I'm going to take acid, that is HCl, and alkali, that is NaOH. It would be forming salt and water. It would be forming salt and water. Whether you are taking HCl, whether you are taking KOH, rather than NaOH, you are going to take KOH. The product would be the same. Criteria is same. Always salt and water. Always salt and water. If you are going to take HBr
Sir, is
and
that KCl plus H2O
yep,
or it's XCl?
KCl,
Okay.
it's K. So it would be forming NaBr. This is your salt. Then H2O. Then H2O. And if you are going to have HBr and KOH, so again you would see that KBr and water. Or these are group 1 hydroxide. Group 1 hydroxides sometime or let's say I can also take this one. I can also take this one. It would be forming lithium chloride, lithium bromide plus
Plus
water.
H2O,
Yep.
H2O.
So again, it would be the same for rubidium hydroxide as well. It's also group 1 member. What would be the product?
RbCl plus H2O.
Good one.
And then RbBr plus H2O.
Am I supposed to write RbCl2, RbCl, Br2, LiCl2, KBr2, NaBr2, KCl2, NaCl2? Yes or no? If not, then why? If yes, then why?
No, because I have to balance it there also.
Sorry,
Sir, no,
why?
because then we have to balance it in the equation.
No, no, this is not the reason. In which group these metals are present?
Group 1
Group 1. So, what's the charge for group 1? 1 or 2?
plus 1.
One.
So that's why I'm not supposed to write 2 in the subscript of in the subscript of this compound. Like it should not be NaCl2. Whenever I would be having group 2 metal, let's suppose if it would be magnesium, so then I am supposed to write 2 because the charge for magnesium is 2 since this is in group 2. Are you getting my point?
Yes, sir.
Yep.
Yes, sir.
So this is called acid-base reaction. And what if I'm going to take group 2 hydroxide? And what if I'm going to take group 2 hydroxide rather than group 1? Like that. Yep. So now I am supposed to write magnesium chloride, calcium bromide, and magnesium chloride, and no, it was calcium chloride. Yep. Magnesium chloride, then magnesium bromide, and then water, then water, then water, then water. Since this is 2, 2, 2, 2, 2, 2, 2, because the charge for magnesium and calcium is 2, since they are in, because they are is in group 2. Okay.
Okay, sir.
Yep. Acha ji. Then you can take any of the hydroxide. I'm talking about group 2. The product would be the same. The product would be the same. Or you can take any other acid. You can take H2SO4 rather than HCl. You can take H2SO4 rather than HCl. You can take HNO3 just like I have used in that like metal plus acid. So let's suppose I'm going to take all the things but H2 is so 4 like yeah. Yes. Okay. So of course the salt would be the change. The formula of the salt would be different. It would be this one. Can you tell me why I'm going to write two, 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 two?
Group 2 metals.
No, sodium is in group 1.
Sir, is it because we're balancing it?
No, the charge for the sulfate is 2. The charge for the sulfate is 2. That's the reason this 2 is for this one.
Yeah.
Let's say I have NaNO3. So right now I'm not writing Na2NO3 since the charge of nitrate is 1, not 2. If it would be 2, I would be writing 2. I would be writing 2. Simple. And if it would be Na2CO3, again I'm going to write 2 because the charge for carbonate is 2. Because the charge for carbonate is 2. Are you getting my point?
Yes, sir.
Okay. So you have to take care it regarding the charges. So, and then now I'm taking group 2 hydroxides rather than group 1 hydroxides. So then you're supposed to tell me the product. Yes.
Sir, Mg2SO4 plus H2O.
MgSO4. Okay. Wait. Why not Mg2SO4? Why not? It's Mg2SO4.
So is it because charge of SO4 is 1?
No, I told you the charge for SO4 is 2, but also the charge for magnesium is 2. So they are both 2. They're going to cancel each other. So that's why I'm not supposed to write 2 over there. It's cancelled with the charge for sulfate, with the charge for magnesium. Are you getting my point?
Yes, sir, because
Yes, sir.
SO4 is -2 and then
Yeah,
Mg is
it's negative
positive.
2, it's positive 2. They are cancelled. Yeah. What is for the next one?
CaSO4 plus H2O.
Good. Good one. And yes, Mariam, what do you think about the third one?
So SR SO4 plus H2O.
Nice. Good. Good. What about the last one?
BaSO4 plus H2O.
Good. So now you're able to write down the products, right? Okay. And and again, yep, water would be the same, but what would be the salt? What would be the salt?
MgNO3. Sir, NO3's charge is -1 or 3?
Yeah, -1.
Okay, so MgNO3.
But 2. Why? Because magnesium is 2. I'm supposed to write
Yeah.
2 over there. It would be calcium nitrate. CaNO3 taken twice. It would be strontium nitrate. And it would be barium nitrate. Okay.
Okay.
Yep. So this is all about the reaction of acids with bases or alkalis. Okay.
Okay, sir.